this isn't acceptable. Well, it's actually hard. I think there are a lot of things you can say here. I'm just going to say one that applies at least to me. It might have some force for you. I'm what's called a Platonist about mathematics. A Platonist believes that the objects that you're talking about in mathematics really exist in some sense. Numbers, geometric objects, and so on. In what sense do they exist? Well, they don't exist around here. You're not going to like stumble into the number 3 or see a geometric circle, in the middle of physical space. You're going to see things that approximate it, but not the circles that we talk about in geometry. So they have to exist in somehow independently of the physical. Okay, so if you accept this, then the thing to notice about these objects, one thing is they don't exist in space and time in the way physical objects do. In particular, they don't exist in time. And so geometric objects, when we do geometry and we make claims about triangles and so on, what we're talking about are not entities that are physical. They're not entities that exist in time. But they clearly are entities that have shapes, because that's what geometry is about, right? Things with shape. So this, I think, is where the primary intuition comes from, that shape really doesn't have anything essentially to do with time, because we can make perfectly good sense of shapes of things, like when we do geometry, totally independent of any question of them having some sort of temporal relativity. So if you're at all sympathetic to the idea that when we do mathematics, we're talking about objects that have shapes, when we do geometry, then it seems clear that the most primary notion of shape is not one that could be a relation to times. And that therefore this does have to be further analyzed in such a way that we can understand where the shapes are coming in and where the times are coming in some independent way. So I don't have any like knockdown proof that somebody is going to be led to contradiction if they're willing to just take these as primitive shape properties and say shapes are in fact relations to time. But I think it's a pretty bad view, and I think we can do a lot better. So the way we're going to do better is going to be to analyze what we mean when we say something has a shape at a time in such a way that really allows there to be something that really has shapes, intrinsic shapes. Okay, so that we don't lose the intuitive idea that the shapes are genuine intrinsic properties. And the way to do that is going to be to argue for a kind of analogy between space and time, and in particular that persisting objects have temporal parts in a way that's analogous to the way they have spatial parts. And it will turn out that the temporal parts are the things that have these shape properties directly, and they have them intrinsically and not in a way that's relative to times. Okay, so now I don't really think it's that problem. Some philosophers, to my endless consternation, deny that they can understand even what temporal parts could be, or the notion of temporal parts makes sense. A famous philosopher, Peter Van Wagen, I don't think that it's problematic at all, and I think we can all understand very easily what temporal parts are. Well, first of all, we already talk about temporal parts with respect to events, right? So you have the notion. All right, so take a baseball game. That's an event that lasts through a certain amount of time, and it has temporal parts, the first inning, the second inning, the third inning. And you can think of the game, the entire game, as just being a sort of sum or aggregate of all those temporal parts. You put all the innings together and you have the whole game. And so with events, there's no problem about talking about them having parts. But what about objects, persisting objects? Well, again, I think it's very much the same thing. If I wanted to map out, my biography, the various things that I've done at various stages in my life, a natural thing to do would be to use, I always did like chalk, would be to use a timeline. Right? timeline suggests that time is a lot like space. So this is PB's life. And you might have birth at one end, and yes, even I, death at the other end. And here I am somewhere in the middle lecturing about Four-Dimensionalism. And I can put various of the events, graduating from high school, and so on. What does this suggest? It suggests that there's a sense in which we think of time like space, right, as being a dimension that we can represent as a line. Now, one difference, of course, is space has three dimensions, and time, we think, only has one, unless you think of time travel, then maybe it has more than one, but let's just assume time has one dimension. But now, as soon as you talk about your life being represented by a line, then, of course, it's very natural to talk about the parts of the line as being parts of you, but they would be temporal parts of you. So there's this stage of me that goes from when I started lecturing to when I end, and that would be literally then, on this way of thinking, a part of me, but it's a temporal part, not a spatial part. Now I'm going to use temporal parts in a specific way as being momentary, so that we'll talk about the temporal parts as being just things that last just for an instant. All right, well, in that sense of temporal parts, and as you're watching me, what's happening? One temporal part replaces another, replaces another, replaces another. So you're actually seeing a series of temporal parts going out of existence, coming into existence, and so on. And what I am is the sum of all these things. So notice this is a view that treats time very much like space. So, just as we talk about something extended in space as having parts, I've got a right half and a left half, if you draw a line down the middle. My life, it divides into parts. It's got a first half and a second half, temporally speaking. And just as you can divide me spatially up into very small, tiny spatial parts, points of space, if you will, or something close to them, you can divide my temporal parts into things that are exist only for very small amounts of time, instantaneously. All right, so, there's a lot to support this way of thinking that time is like another dimension, and a lot of the best arguments come from physics, but it's interesting that we have reasons and argue just on philosophical grounds to think of time in this way. But I might mention from physics, you're probably familiar with space-time diagrams from some even just high school class, right?
Use that marker here, bottom right.
What's that?
Over there.
Wow, what a difference. Okay, so you might represent time that way, distance this way. We can kind of draw on the board, a y-axis too, if you want. A plane, so we have the xy plane. I'm not going to try to draw a z-axis too, because that's pretty impossible. But space-time diagrams, at least we can get then two spatial dimensions in one temporal dimension. And then, in these diagrams, you're thinking of a persisting object as something which occupies a region of what here is called space-time, because it combines space and time together. So let's just give an example of what it might look like. So if I'm just standing here, and then I move off to one direction, and then come back, how would you represent that as on a space-time diagram? So for a while, I was just standing there. Then I went off to this direction, then I came back, and now I'm standing here. So you see, we can show motion on a space-time diagram. Now, what am I? I am something like this street. Right? That's what represents me. And it's going to, since I take up some area on the xy plane, it's going to have a certain amount of volume. And these things are called often space-time worms, because on this way of depicting persisting objects, they tend to, they're not very wide in the spatial dimensions, but they exist for a while in terms of, so they're like little worms that go through space-time. So almost space-time worms. All right. Now, obviously, we can depict, this was change of motion, but we can depict change in shape, like sitting and standing also. So when I went from sitting to standing, well, it's kind of, I'm not going to draw this very easily, but my area in XY plane went from being broader to being narrow. When I'm standing, it's narrow, right? So you could sort of show like, when I'm sitting, I'm taking up more space, and then I stand up, and I'm much narrower, and then I go back to being sitting, taking up more space. And so this would sort of be the way I would, the space-time diagram in the book, if I ignored the z direction, where I got up and down, just looked at the XY direction. So anyway, we're depicting change now in these diagrams. And how is it being depicted? It's being depicted by looking at the various parts of me. What I am is the whole worm. You look at, well, going back before this and after, but we're looking then at the parts and noticing that the parts change. This part was thicker and squatter. This was narrower, and then back to being thicker and squatter. And so the fact that the parts have changed shows that I've changed as a single persisting object. Alright, so four-dimensionalism is, different people define it differently, but it's basically the view that time is sufficiently like space to be thought of as another dimension of space. And one of the analogies, one of the ways in which it's like space, is that things have parts in time, temporal parts, just as they have parts in space. I might mention two other ways in which it's analogous, and typically with respect to the reality of things that are distant in space and time. So, just as we think that distant objects are just as real as objects that are nearby, Mars and Alpha Centauri are just as real as you and I. Things that are distant in time, like the dinosaurs or some future race of humans, are just as real as we are now. So, on this picture, there's a sense in which the past and the future are all equally real with the present. Another feature which is related to that one is that there's nothing special about now any more than there is about here. I mean, is there something special about being here? No, it's just the place I'm at. And here is only notable because I'm there. So it's just something relative to me. You're at a different here, so to speak, and your here is just as good as my here. Well, the same is for now. I mean, there's nothing special about the time that's now. It's just where I am now, where I'm at. At some future time, I'll be at a different time, and I can correctly call that one now, and that will seem special to me then. But the future nows, things I call now, and the present now, and past times I call now, are all equally on a par. There's not any way in which one is somehow special. So that's another way that space is like time. Now is no different from here, and now we should understand its metaphysical significance. All right. Now, one thing to say, though, about four-dimensionalism, you don't have to believe that time is like space in every respect. It isn't. I mean, one thing that's different about time is that it seems to have a direction. You don't think space has a direction. So, four-dimensional doesn't have to believe time is the same as space in every sense. Just the fundamental ones of which. Alright, now. Let's go back to the problem of change. It's immediately solved. We do now have a simple way of analyzing what we mean when we say something like PB is bent to T. So if this is a time at which I was bent, this is a time at which I was standing, so straight. PB is bent at T means PB, which is the whole worm, has a temporal part that exists at time T. Here it is. and that temporal part is bent.